Hey everyone, welcome back to the Savage Sullivan Math website. Mrs. Sullivan here. I'm going to talk to you today about multiplying a binomial by a trinomial. Pretty cool stuff. It's not a whole lot different than what we've already done. It's just a trinomial instead of a binomial. So we're going to deal with this the same way we did double distribution with the binomial multiplied by a binomial. We need to take this x and we need to multiply it by every term inside of the parentheses. Holy smokes, that's a lot of multiplying. So I'm just going to write this out so we are clear about what we are doing. We are doing x multiplied by the trinomial of x squared minus 2x plus 4. All right, then we need to take this plus 3 and we need to multiply that by every term inside that second parentheses. So remember, it's a positive 3 that we're multiplying, and that gets multiplied too by an x squared minus 2x plus 4. So let's just go ahead and crank out these multiplications. Don't forget your laws of exponents. X times x squared will be x cubed. X times a negative 2x would be a negative 2x squared. And x times 4 is going to be a positive 4x. All right, over here, we've got 3 times x squared, which is going to be a 3x squared. 3 times a negative 2x will be a negative 6x. And 3 times 4 is going to be 12. Okay, this looks pretty wicked right now, but we can simplify this because we have some like terms in our midst. We just need to look for what are like terms. All right, do I have any other cubes anywhere? Doesn't look like it. What about squares? Do I have any other squares? Ah, yes, right there. So I've got a like term there and a like term there. What about plain old x's? Do I have any other x's? Yes, right there. Okay. And then a plain old constant? Nope, nothing to match up with a plain old constant. So we want to make sure that we write our answer in standard form, which means we need to have the highest exponent first to the least exponent, or the greatest number of variables first to the least number of variables. So cubed wins. Cube gets to go first. X cubed. I can't combine that with anything, so it's just going to come down as it is for our final answer. All right, squared would be next then, and we can combine these. Negative 2x squared plus a positive 3x squared. Negative 2 plus 3 is a 1x squared. All right, we've got our plain old x's next. So 4x minus 6x would be a negative 2x, and then our plain old constant is 12. Just double checking one more time. I don't have any other like terms, so I've combined everything that I can, and this is our final answer. X cubed plus x squared minus 2x plus 12. Whew!
I am in awe of the awesomeness, Mrs. Sullivan. Nice work. Let's try another one. So let's say that I have the binomial 2x minus 4, and I'm multiplying it by the trinomial 3x squared plus 2x minus 7. Now, like Mrs. Sullivan said, this is just like double distribution, except I have an additional term in the trinomial that I have to multiply by. Now, I like to call this the clamshell method, and you'll see why after I'm done, but that's always how I refer to it. So just like Mrs. Sullivan did, and I show my work slightly differently, but we get the same answer, I'm going to start with 2x, and I'm going to distribute the 2x first to the 3x squared. What is 2x times 3x squared? That would be 6x to the third. Next, I'm going to take 2x, and I'm going to distribute it to the 2x over here. 2x times a positive 2x is a positive 4x squared, remembering our exponents there. And finally, I'm going to take the 2x and I'm going to distribute it to my last term, which is negative 7. 2x times negative 7 is a negative 14. Now I did my first term of my binomial. I still have to work with the negative 4. So I'm going to do the exact same process, but now I'm going to do it with the negative 4. So what is negative 4 times 3x squared? That would be negative 12x squared. What is negative 4 times 2x? That's an 8x. And last, negative 4 times negative 7 is a positive 28. Now I have this huge long polynomial that I have to combine my like terms with. And I'm going to pause here because this is why I call it a clamshell. So to me, these lines and these lines, had I had a little more room to draw them, to me this whole thing looks like a clamshell, which is why I call it the clamshell method. So I'm going to go ahead and I'm going to combine my like terms, and I'm going to make sure that my final answer is written in standard form. So when I look at 6x cubed, there is nothing I can combine with 6x cubed. There are no like terms, and it's also the highest exponent, so I know that that's going to go first. I have positive 4x squared minus 12x squared. What would that be? Yep, negative 8x squared. Again, I'm writing that next because I know it's the next highest exponent that's going to come. Then I look at this and I see that I have just one term that has a plain old x in it. So that's going to come next. So plus 8x. And then finally, I'm going to combine my constants. So negative 14 plus 28. We want to watch those signs. We want to make sure we're really careful. When we combine those, we get a positive 14. So I'm going to take one last look at my polynomial. I'm going to make sure there's nothing I can combine, which there isn't because none of these exponents are the same. And I'm going to make sure it's in standard form, which it is. So that must mean that 6x cubed minus 8x squared plus 8x plus 14 is my final answer. Pretty cool. If you found this video helpful, please like and subscribe.